Let's get started. Okay. Um, Super excited to do the session. Let's start by introducing Neha. If this will move. Okay, there. Oh, actually, let's start by introducing the mission of STEAM Ready. So STEAM Ready is an initiative committed to making STEAM education accessible, inclusive, and engaging for everyone. And so we're doing this by increasing access to STEAM education resources. And so we have a bunch of different resources on our website at steamready.org. These include things like lesson plans, worksheets, and then a list of different opportunities that people can go to or use or take advantage of. And we also have an Instagram account that helps educate like users on Instagram about different areas in STEAM, and it gives some useful information. So we feature professionals like Neha here through STEAM Machines is what one of our programs is. And we like to show people what the opportunities and career paths are in STEAM. And so we're also improving higher education and career readiness, especially with these Q&A sessions, so that people can get more of an idea of what they want to do, or if they want to ask questions, they have the opportunity to do so in these Q&A sessions. And we're also inspiring youth to pursue their STEAM passions by empowering them and providing role models and increasing awareness on different issues like the wage gaps and inequalities in STEAM, and while also promoting opportunities and eliminating education and quality gaps for minors in STEAM. And here's a little introduction on Neha. She was born and raised in India, went down the electrical engineering path, pursued a master's of electrical engineering from the University of Florida, and is currently working as a space systems engineer at Iridium Communication, where she manages the health of computer software and hardware on satellites. So welcome. Thank you so much for coming. And we'll,
Thank you so much for
yeah,
having me. I'm
yeah, of
excited.
course. I'm super excited as well. We'll start by asking, what is engineering and what do you think it is and why is it important?
So for me, engineering is anything that you're applying math and science to build something or to solve problems that are going to make your life better, is what I see as engineering as. And being obviously when we say, oh yeah, I'm an engineer, your mind goes to, okay, like, 4-year degree and stuff like that. But just, if you go down to the basics of it, just stuff like, I always think of like things that are as simple as, you have your kitchen utensils that somebody invented a long time ago to make things easier. Things like, we always speak of the phrase like, oh, reinventing the wheel. And I would see that as somebody, great engineer back then, whoever, or, whatever, if maybe it was a progression, but stuff like that is also engineering to me. So anything really that is just you're building something using those concepts of mainly math and science.
Thank you so much. Yeah, I love how engineering is able to like make a bunch of different things that help make our world much more useful and easier for people to like live in. So
Right,
yeah.
exactly. Yeah. And yeah, and sorry, the second part, I just remember you said the second part of engineering of the question where why is it important? Um, so again, obviously because, well, it's making our lives easier most of the times, but also a lot of times there are things that are life-saving even, right? If you think about things that are built as safety mechanisms, for example, our cars keep getting better, right? They all keep adding safety features. The the cars themselves, the way they function, are built to make you more comfortable, more safe. And I think the importance of engineering comes in there, just the safety factor of it, where engineering has led to not just that, just they've increased the longevity of humans with all the things that are, be it engineering in space or engineering in in just everyday field where you're talking about, say, for example, chemical engineering or things like nuclear engineering, which can be, a double-edged sword, but it's if you look at it from a high level perspective, it's making sure countries are staying safe and stuff like that. Power engineering, where things are, from both an a fossil fuel versus, and now that everything is going electric, from that perspective, things are becoming more enhanced, just making our lives just better and safer. So the safety factor there for sure. Especially in the last few years, I feel the emphasis has been so much on the human part of it, and not just like, oh, we're just doesn't matter, right? It's for science. Well, the human life, the lives of even animal life that are used in testing and stuff is important. So I like that is engineering makes that better going, and hopefully we continue to do so going forward. So
Yeah, I love that answer so much. Yeah, that really resonates with me, and I love how engineering is just such a wide area that you can like apply these concepts to and build each solution for different types of problems. Thank you so much.
yeah.
So what we want to ask next is, what was your childhood like? Did How did you end up wanting to pursue electrical engineering, and how was STEAM a part of your life in your childhood?
Yeah, so I was, like it said in the introduction, I was born and I was raised in India. I was born in Mumbai, raised in a town close to Mumbai, and I'm an only child, so I was always drawn to like books and puzzles and stuff like that to keep myself entertained. And as as this kind of the stereotype is, like, it just in India things are very, kind of academic heavy in school. So you're kind of, I don't want to use the words force, but it's everywhere around you. So that was a very, everybody around you was like, oh, this, I'm an engineer, or I'm a doctor. And it was interesting because I remember in middle school being like, I would never do that. Like, that's not, I will never be the stereotype and this and that. But I was really drawn to math and like physics. I didn't like chemistry as much, but I used to love physics and math. And I was just drawn to it just because of maybe the puzzles I used to do as a kid and stuff like that. And very soon, I think by the time I entered high school, I was pretty set that I want to do engineering of some sort. I wasn't sure. Um, I first thought about computer engineering, and but I wasn't sure. So when I enrolled in school, the major there was called electronics and telecommunication, which is really kind of like electrical engineering, but you have like a like signal processing courses and stuff like that added in there. And there was one programming language that I had to take the first year of school, and very quickly I knew that I did not have the aptitude for coding, and I was like, well, the other part of the electrical engineering part of it sounds interesting, and I was fairly okay at it, and so I continued that path. And then by the time I was done with my 4-year degree, I realized I wanted to now even continue and pursue my master's. And that's when I applied to a couple of schools in the US, and I got into University of Florida. So go Gators. And it was a very big kind of a change in how the learning process was. The pace was different, and of course I understand that the master's program is a little more rigorous than what you would have in a typical 4-year degree program. But just it was just different. The type of teaching, the type of courses, the teachers, just everything was very different. So that was a pretty big kind of like and add to that the culture shock of being in another country. It was a rough first semester. I'll say that, but kind of got the hang of it, and very slowly but surely started to love every part of it. And it was, yeah, it was challenging, but it was fun. It ended up, hindsight, right? Always. It was really great. So yeah, I think it was just I was drawn to it mainly because of math and physics, those subjects that I liked in school. And I knew very for sure that the subjects that I didn't like. So I used to always shied away from like history, geography, like the environmental sciences and all of that stuff. So it kind of, the method of elimination made it a little easier too, I guess. um but yeah, that's where it went. And it was early, I guess, my childhood. It was all this that led to engineering, but not that's not all I did. Thankfully, it was, we did do our we spent a lot of time in school, right? It was majority of the day was in school. So sure, it was very academic oriented, but we had a lot of extracurricular where it's not as much sports, but other things, like where Indians are very into song and dance. We used to have a lot of dance competitions, and stuff like that. So I was very inclined towards that. A lot, we used to have like drama, and a lot of I was very good at debate. We used to have a lot of we had like a little bit, I wouldn't call it a club because there were like 3 people, but we had a debate thing that actually got very, very popular very soon. And then by the time I left, there were like 15 people in there, which was kind of cool. But we did a bunch of that. So yeah, that's what childhood was like.
It's good to hear about your childhood. It's so cool to hear about like different stories and how people got into their field in different ways. And yeah, I can definitely relate to how certain subjects click more than others. I'm definitely not like a
Sure.
math person. No, sorry, I am a math person. I'm not like a English person. So yeah,
Right.
that's very relatable.
Right.
Yeah, and so our next question is like, what was your university education like? And can you tell us more about like the specific classes you took and I guess what subjects you had to study in order to obtain both a bachelor's and then like a master's degree? And maybe you can like elaborate a little more on like how different the universities were in the India versus United States.
Yeah, sure. So yeah, like I said, so undergrad was electronics and telecommunication. So the like we had a bit of flexibility in the courses we decided back in, and it's kind of based on the school as well back in India, but mostly it's like at least the first 2 years of your coursework is already set. It's not like you're choosing your classes like you do over here. So that's a little bit different for sure. So you go in, and so if you, for example, for me, I chose electronics and telecommunications. So I would get a list of the courses that I would be taking for that following year, not just a semester. It would be like drawn out for me over the year. So you wouldn't have your books and everything ready for the entire year. And I think the courses I started with was the first year they give you a bit of everything. So I had mechanical engineering, I had a CAD class, I had introduction to C and C++, which is where I realized that I cannot do programming. Introduction to electronics, where the basics of like, because it's an electronics and telecommunications course, the EE part of it, right away the first year they started with like diodes and transistors and the basics of semiconductors and stuff like that. And then I think we had I don't remember if that was the first or the second year, but we had like a digital communications class, which kind of had a little bit of like very basic like RF stuff, pretty much like talking about like filters, how do you, build like an electronic filter and stuff like that. So that was the first year where, we even had like, yeah, I think we had like civil engineering too the first year, because I remember doing like drafts and stuff, which was, so first year was very intense because you're like jumping from, you have to like, you're in a mechanical class and then you're like forced to abandon that and suddenly look at like, diodes and everything is new, right? You're coming in from high school. So that was a little weird, but I think the goal of the program is to kind of expose you to everything. So that way, you kind of get that first year to make up your mind. And then if you want to change into something, which a lot of people from my class did, a lot of them, there were some people who were like signed into like a mechanical class. They were like, well, no, we don't want to do this, and they jumped on to like computer science or even otherwise. So that was the first year, and then the second year is where if you stick to wherever you want to stick to, which I did for electronics and telecom, it starts to become kind of focused on your major then. So then the second year we had a bit of more like kind of hardware programming. So it was like an assembly language class. I remember that they started, which made me feel better because it just made more sense to me than C programming for some reason. So we started with that, and then second year was again from the semiconductor perspective, got a little deeper into just how are like op amps, for example, and stuff like that. And then the telecommunications part too. I think we had a digital signal processing course. Again, it might have been the second or third year, but somewhere around there. And then the final year was more of a big chunk of our final year was a project. Like you pick like a project to build. So back then it was a lot of like the computer to like the voice over IP stuff was like new. So a lot of the projects a lot of people did was like, oh, from SMS from my phone to the computer, stuff like that, which again probably seems elementary right now, but like this was 15 years ago at least. It was like the thing, and we didn't. I think even Skype came like a year after I graduated and stuff like that. So projects like that. Some projects used to be like kind of hardware intensive, where you're building like I'm trying to remember some of the projects my friends did, but because mine was voice over IP, that's what I remember. Some of them would, if they were like mechanical related, they would make like literally make like a little robot, right? Stuff like that. So that took a major chunk of coursework, and because you would try to kind of match your coursework to your project kind of thing. And then there were everything there in third and fourth year was divided into, we call it theory and practicals, which was lab work really. So we would, you got to go and, one of your exam would be like, okay, the teacher would give you a circuit and you kind of like solve for current here and measure it on the multimeter, right? So it would be like a basic circuit, and you make sure you build it as the calculations go, and then you measure like the resistance and measure the voltage, and then you have to record that, and the teacher will come by and the professor would come by and see it like, okay, yeah, all right, fine, that makes sense, or it doesn't. So it was the third and fourth year that way was pretty intensive, but I enjoyed it more because you're kind of like watching your work, like you're looking at stuff that you learned about like 2 years ago kind of thing, and it was it made a little more sense. So that was pretty fun. And so that was like kind of the and which is a pretty standard like flow of engineering coursework in India. And then coming over here, that was a huge change in just the way things are taught here. So first of all, I was like, well, courses, what, I have to pick my courses, I'm not sure. So I talked to people, I was seeing what my friends were doing and stuff like that, made very poor decisions the first semester because I just, a lot of times I just like did what my friends were doing, right? And it wasn't the best decision for me because everybody around me was very like computer programming centric and I wasn't. So I realized, well, so the first semester went that way, and then after that I went in and kind of redid my, okay, what's the thought process kind of thing, and then actually went and spoke to the professor for once, which is also I wasn't used to that because that's not something we did in India. You just go to them if you have like a technical question, or or most of the times we would just ask somebody who was a senior to us, like, oh, why don't you teach me, versus going to the professor. The one reason also for that is the class sizes were huge in India, right? So there was also not a lot of like one-on-one professor time that you could get, or we didn't have anything like TAs or RAs and stuff like that. So it was a very like kind of like a community effort. You're just like band together with your project mates and figure it out, right? Which we do here too. But I feel like the resources, I didn't realize how many resources I had until I kind of like eased into it after the first or second semester. So that was a very big change, but it was good after I understood how everything worked, and coursework and stuff like that. The exams, the way they were graded was so different. Like, I was like, what curve? What is a curve? We didn't have any of that back then, so it was very interesting to go through that as well. So yeah, I'm sorry. I think I heard a mic. Did someone have a question? Happy to answer. Okay, but yeah, that was definitely a big change in pace too, I would say. And yeah, the fact that I had to go to, like, they were like, oh, the professor would be like, well, go to the TA if you have questions. And I'm like, what, who's the TA? And took a while to just get on that page, but it worked out. Second year was way smoother, I would say, and the courses were very intense. I have to say, even though we would have like, it would be like a 2-credit course, but and it's also probably the difference between masters and undergrad, that master's program they're just more intense that way, technically, especially. But learned a lot too, so it's great.
Thanks so much for sharing.
Yeah.
It's super cool to learn about like what classes you go through and like what your experience is like in university. Thank you.
Yeah, thanks, no problem.
Our next question is, what is Iridium, and what is Iridium's mission, and yeah, what do they do?
Yeah, so Iridium is a satellite communications company, and it's the only one that has been providing true global access for like voice and data services. And that's been true since, like we were talking about the Block 1 satellite, it has been true since we had Block 1, not just the next thing. So yeah, that is, I honestly, like, the official mission, I'm not sure what Iridium's of, but really the mission has always been, true global coverage, for sure. And we continue to do that pretty successfully. So for the next satellite constellation, we have 80 satellites in total, and 66 of those support like what we call like support mission, which is supporting the services, right? So they're actively doing the voice and data service transfer. And then we have 14 what we call the spare satellites that are kind of like just kind of around there as backup. So if one were to fail, we could always use one of those 14 ones. So yeah, that's our satellite constellation that we have. And the unique part about the Iridium satellites also is that they talk to each other, not just to like something on the ground, not like they just always talking to something on the ground, which is why we have that global connectivity, because they're talking to each other, and that enables, and that part is also a pretty complex architecture, has been since Block 1. So I always, excuse me, I always found that part of the Iridium satellites really cool, that they talk to each other. So
Satellites are super cool. Lily, do you have a question?
Yeah, I do. So why did you pick, when you were picking companies, why did you pick Iridium, like over NASA or SpaceX or some of the other big space companies?
sure, it's a good question, and I'm going to go back to where I started career-wise to kind of answer that. So yeah, obviously, right? It's like I'm an EE engineer, and I started right after school. I did start working for a semiconductor company called Microchip, and it's also based here in Chandler, Arizona. So I did that for a while, and I landed in Iridium, or in really in the space industry, because my husband works he's an aerospace engineer, and he started working. So we were in school together at University of Florida, and after we moved here to Arizona, when I was working, he started working at Iridium. And that's when I kind of got exposed really to anything aerospace. Before that, which we were talking about the iridium flares, right? So didn't even know what stuff like that was. And then I really got introduced to the aerospace industry like that. And that's how I ended up at Iridium, because we did a move to Virginia for work again, and I had to give up my company, and I was really looking for work. And in Virginia, that's Iridium has our operations center there, and I knew it's a good company to work at. My husband worked there, so I applied and got in. So that's how I landed there. But yeah, thank you for that question. That was a good flashback for me.
Yeah, thank you so much for that story. That was amazing. Okay, our next question is, what is your job and what do you do as a space systems engineer, and like what kind of projects have you been working on?
Yeah, so as space systems engineer, so I'm in charge of the onboard computer on the satellite, and that takes care of the payload hardware, which is the payload is the hardware that provides all the services, right, that I talked about with the voice and data. So that onboard computer is really like the heartbeat of the satellite, because that enables communication that the rest of the payload hardware and modems provide to the other satellites, to the ground and stuff like that. So really just managing the health of that computer, making sure we always have an uninterrupted service. And we do have anomalies. We have issues sometimes that the computer starts to reset, for example, or starts to have just faulty behavior that is not expected. So that's where we kind of come in, see what's going on, troubleshoot the problem, fix it in the least amount of time we can, and really just make sure that we're back into service. So that's the big part of the job. And in terms of the projects that we do, so one of the main things that we kind of do like periodically is, like, because things are changing, we keep adding services to what we can support as a constellation. We end up kind of updating the software on orbit. So that computer on orbit will just like pretty much put in, like, it's like a new version, like you would update your phone, right? So it's really just like that. You're adding more services, so you update the software that you have on that computer. So we have to do that on all 80 of them, so it takes a bit. Some of them have some unique configurations that we have to worry about and stuff like that. So that comes in like every few months as a project. Other things are, we try to improve what we have currently on board. Obviously, we can't do anything with the hardware because it's up there, but are there any things that we can probably automate, stuff that maybe can the satellite fix itself if there's an issue? So we try to kind of work on projects like that to see if we can do something little that we can configure to, we can and we have like almost like, think of them like almost as switches that you can play around with, that can be configured to do certain things or not do certain things. Because sometimes you would do something and realize, oh, well, that's not working like it should, turn it off. So those are also part of the things we have to kind of worry about, where, oh, what's the backup? So those are really what I would kind of call like my projects or tasks on a day-to-day basis, really.
Well, thank you so much for sharing. it's super cool, like all the work that you do and learning about all the specifics of like your job. Thank you.
It
No,
is really
she,
cool. And oh, go ahead. Sorry.
yeah, you keep our SB 9603 SBD modems going that are
Oh,
inside this.
very cool.
Yeah.
Nice. I didn't realize you have one of those. Very cool. Yeah, SBD is what I hear. I'm not very in tune with like all the service stuff they do, but they're like SBD is like the most kind of like the robust thing, just because it's just, it's little data, right? So it's easy to work with, but powerful. Yes. So
Yeah. I love being able to sit at my desk in Montana and command things in Australia.
oh, very cool.
Yeah.
Very cool. And is that like your personal thing, or are you doing that like is that work stuff?
It's work stuff, company
Work
called
stuff. Okay.
Geoforce. Yeah.
Oh yeah, I did see your when we got introduced. I was like, oh, GeoForce. I didn't, and Ian had mentioned in the email like, oh, that's they partner with us quite a bit and stuff like
Yeah,
that.
we do.
So that's really cool.
So that
Very cool.
Iridium can connect the world through satellites.
Yeah, for sure.
Okay, our next question is, what is your favorite part of your job? Do you have like any specific favorite memories or like a specific activity or project that you like?
Yes, I love answering this question because I feel like, and again, I haven't gone through a lot of jobs, but I do see around me that once you're in a job for a couple of years, things can get stagnant. You're doing the same stuff over and over again, and just with in general in Iridium, and also specifically the team I work with, because we're always in direct contact with the satellites, there's just constant learning on the job every day, almost every day something new, right? Which is just, I feel it's so cool that even after I've been here not that long, it's like it's been 6 years, but it can get very like, same stuff every day, very fast, which happened a little bit in my previous company. But with Iridium, just the pace, and sure, it comes in waves. You would have like slow days, and then suddenly you have like messages at 3 in the morning that something is wrong, with the satellite. And while that can get frustrating sometimes, but that's what also keeps me on my toes, and I love every part of it, because you're not gonna get, it's almost always that the signatures are new, right? You don't see behavior that's repetitive, just because just the nature of the satellites. So that part, and then just you're learning, and then if you have issues, you're troubleshooting. So that's obviously you're learning there as well. So that's definitely my favorite part of the job, and just always something to learn. And if even if nothing eventful is happening on the satellite, just learning about the satellite, that just so complex. And I don't, there's a lot of experts at Iridium that know quite a bit, and just learning from either from them or just from the documents in general. It's just, there's always so much to just read, right? This still is just to find out what's really up with or what really goes into the satellite, other than my own kind of pocket of like subsystem. So that's really cool. And in terms of memory, yeah, that's, I was lucky enough that I got hired right when we were in the middle of launches. So we were launching the next satellite. So that was when we talked earlier about the Block 1 constellation being replaced by the next. So I came in when we were when we were right between launches 2 and 3. So we had just done launch 2, and we were in the middle of, or we were, getting prepped for launch 3, and I'm just thrown into the mix. And nobody has time to stop and, tutor me or teach me. They're just like, follow along, right? And I remember that I was in Virginia at the time, and we were in the control room, and they, launch was successful, they announced. And then it kind of like, it depends on where we are, like where the trajectory is. So it takes a good, like sometimes 45 to 50 minutes until we get like, we acquire communication with the satellite. So everybody is like waiting, and our like the K-band engineer, which is the K-band is where the satellites talk to each other, is the spectrum. And they had like, and I had no idea what that graph meant, but they're on their computer and they see, just kind of like data coming in, right? So they saw like the packets increasing or whatever that meant. I still don't know what exactly he was looking at, but you just see it coming in. He's like, yes, we have contact, we acquired. And I was just like, wait, did you just like talk to that satellite? And I'm coming in, I'm new, I have no idea, what any of this is. And that was, just such a core memory to me. It was really cool. When they said that, and everybody was kind of like started to celebrate, and then it got quite quiet again because they were like, oh, the second one's coming in, the third one's coming in, because we had 10 of them on that one launch. It was really cool. So that's definitely my favorite memory.
That sounds awesome. I would love to
It
like
really
be able
was.
to experience that. Lily, do you have a question?
Yeah, I do. So I remember you saying that sometimes you'd have trouble with the satellites, like sometimes they wouldn't function or they just wouldn't work. How
Right.
were you able to like get the mindset to like push through to keep going and keep trying to fix it?
So the biggest thing is really the revenue. If you don't keep the services going, we're losing money every minute we don't have the service going, right? Because communication to our subscribers, communication to each other for the satellites is really the most important. So there's always that sense of urgency where we have like meetings whenever something were to go wrong, and the focus is always how quickly do we solve this, right? And a lot of times it does get a little challenging because as an engineer, sometimes you want engineering data. So you would want to tell like your manager, like, well, why don't we wait and get some data and look at diagnostics a little bit before we do so and so action that will just wipe everything out maybe. And they're like, well, no, that's not an option because we need to get the satellite back and healthy as soon as possible. So it is when you say what drives us, it does get a little challenging because you want, as soon as something were to not function, you want to look at like the long term, right? Like, oh, how do I make sure this doesn't happen again? But at the same time, we also want to make sure that we need to bring it back functional as soon as possible. So we work kind of like try to figure out a balance, I guess, of how do we do that. But the drive is really because you're almost like handicap, and somebody came up with this, which is at Iridium, which was such a good kind of analogy. He was like, there's a hole in the fabric and we have to fix it, right? Because you really imagine all the satellites talking to each other, and one of them suddenly is not. So now you have 4 other satellites around it that are looking for this one in a way, right? So you really gotta kind of stitch it back kind of thing. So that definitely keeps us going.
I love that fabric analogy. Yeah, I
Right?
think
Yeah, I have
that's
no
a
idea
good
who came with
visual.
that, but exactly
Yeah.
that made so much sense to me.
Yeah, it definitely like helps my brain make sense of it. It's so cool that it's just like an entire network so strong. It's like fabric, like that
Yes,
analogy.
it
So
really
cool.
is.
Our next question is, what advice do you have for aspiring engineers or people looking to go into STEAM?
So I guess two pointer. So the first would be, of course, just to like do your best, and things will kind of just follow. As long as you do your best. And the other thing, which personally for me is the big one, is really just to like step out of your comfort zone. And I know it sounds very cliched, but really, and I'll share my personal experience about just moving through. through moving my career path a little bit, and also the fact when I was talking about my stuff in school, when I kind of moved from India to here, it was very, very intimidating. And there were times where I figured like, oh, maybe I should just stay here in India. I'll find a job and I'll do whatever. But I'm so glad that I did that. I had the support. My parents kind of also like, pushed me a bit like, yeah, just, go do your thing, follow your dream kind of thing. And it was, best decision of my life, really, one of them at least. And even once when I moved to Iridium, I was working in semiconductor, which was, you're going from design, like almost like the other end of the spectrum, to like a system level job in a very different industry too. I had never known much about the aerospace industry other than, just look at NASA launches, SpaceX launches and stuff like that. So when I did that, it was the first few months really were, again, and because I was thrown in the middle of the launch, it was very intimidating, very daunting, like things, people would throw these words around that made no sense to me and abbreviations that made no sense to me. So definitely I used to kind of like feel like, like an outsider, like I don't know what's going on. But very soon, kind of like started to catch up. I had, I'm very lucky to have great like coworkers and mentors that helped me through it too. But really going back to the gist of it was that, just stepping out of the comfort zone. I could have tried to stay in the EE industry, maybe look harder for, I don't know, another job, maybe just to, but I was like, well, let's see, there's an opening, they accepted me, I gotta try it. And I love working here, just the stuff that I said about the learning and the coolness of the constellation and all of that. And again, as an EE engineer, you would think that, oh, what does she do in aerospace? But once I got into the industry, I realized that the majority of the work is really, is where you would need an electrical engineer or computer engineer, because they're flying computers, right? And not that you don't need aerospace engineers, but it's almost like they're it's almost like compartmentalized, right? They do their thing, they make sure that, oh, we don't have any collision with debris. They make sure that we don't have any problems with how the satellite is pointing and stuff like that. And that's very important too. But then the brain of that satellite is a computer, and it's got hardware, it's got software, and that needs to be maintained, that needs to work together, and that needs to be improved. So stuff like that, and you do need your electrical and your computer engineers, which, and now that we have so many aerospace industries cropping up, you can tell if you look at people from SpaceX, so many of them are. I have friends that work for SpaceX that are electrical engineers, people I went to school with. So it's kind of changing where that stigma of like, oh yeah, aerospace industry needs aerospace engineers. Well, sure they do, but they also need, especially these days where everything is so like, everything is just more virtual, more software heavy, that it's the norm that you have all of these majors also supporting aerospace, which is just really cool. So yeah, just getting out of that comfort zone, as scary as it is, I think that's where all the growth is. And in terms of how happy you are with what stuff you do, sometimes might not work out, but it might too. And that's where you got to find out, getting out of the comfort zone.
Thank you so much for sharing. Lily, do you have a question?
Yeah, so I remember you saying like stepping out of your comfort zone is one of the most important things. But what was like another big step that you had to take to like get to where you are now?
I want to say, I would say like just persistence, just like you got to keep going. And I will go back to, again, just the time when I moved to the US. There was, I remember this very vividly because it was just not a fun night. It was a rough night for me, where I was in my a lot of students, what they do is they do their 4-year course, like the degree, and they take like about a 6-month or a 1-year break to prep for their GRE. to apply for schools here. And for whatever reason, I decided not to do that because I thought I would change my mind maybe in those few months of not doing anything. So I was trying to juggle schoolwork while prepping for the GRE. And I remember it was like 2 days until, and you take these like if it's kind of like the preps or even like for SATs, it's very similar, where you have these mock tests and stuff like that. And I remember taking one, I got like a super low score, and I was like, all right, that's it. This is a stupid idea, and I don't need to. I'm not even good at this and stuff like that. It was just a bad day, right? And I didn't really have anybody to talk to at the time, and I realized, well, it was very late at night, and I'm like, this was a bad idea. I'm probably very tired. It's very late in the night. I had a whole day of school. Of course, I didn't do well, and I just somehow pep talked myself like, all right, I'm going to go to bed and try this again tomorrow. And the next day I woke up, I'm like, all right, I'm too freaked out, I got to try again. And I did another mock test, and I ended up getting like a 1400, right? And I was like, all right, thank God I didn't just be like, all right, whatever, screw it, I'm not gonna do it. So I think, and there have been, that's one of the memories I remember, but there's been other instances where you just feel like, oh, I'm not sure, and then you're like, well, I'm here, might as well do it, and just let's just go through it, kind of thing. And it just ends up being such a good decision in hindsight, because you go back and you're like, oh, thank God I didn't quit, or thank God I didn't change or let myself change my mind in a bad way. So I think that for me personally has helped to just be like, I just say like, well, it could be worse. I'm here already. Just keep going. Might as well. So
Yeah,
I hope
that
that
feels
answered the
good to
question.
know. It feels good to know that I can keep pushing through even when things get hard. So that's good to have like a role model like you.
Oh my God, thank you. That means a lot, really. I'm so glad
Mhm.
I helped in any little way. Thank you. That means a lot.
Yes.
But yes, definitely keep going. And the comfort zone kind of comes with that too, right? Because that's kind of you stepping out of your comfort zone to where you're like, oh, I gotta push a little bit. And well, worst case, it's not going to work out anyway, but then you tried your best, right? So
Yeah, this is such good advice. Thank you so much. And you really are such a role model.
oh, thank you. That means a lot, really. I'm so glad I could help. And that was one thing I was actually gonna talk to you when we just started, was to also like I'm also on Insta, so I'll give you my handle, and I'm always available. So if you just wanna like, not through anything official, but if you just wanna IM me for anything, or I'm always very, very happy to help. So
Okay, sounds good. Yeah, I'll ask you at the end for that. And
for
then
sure, I'll
is it
share
okay
that.
if I share it out to
Yes,
everyone? Okay,
yes,
sounds good.
for
Thank you.
sure. Yeah. Mhm.
Yay. This is awesome. Great. And then I think this is our last question. What is your favorite planet and why?
Oh, my favorite planet. Let me think about that. I'm gonna say Jupiter. And I think I would say that because it's like always so visible to the naked eye. And so this is the thing I kind of do with my 4-year-old, and my husband does this too, where we just try to like just show her stuff whenever we're out there in the night sky, and he does moon phases with her, and I do just stargazing, right? So I would let her look at the like the night sky app, and she would look around and find the constellations and find the planets. And planets, they relate to, she's little, so she relates to that more because she has books about the solar system and stuff like that. And that's one of the things we do, where I kind of tell her like, oh, where's Jupiter, and she'll try to find kind of like it's really bright, and then she would look for it. And one of the things which she thinks is super fun, she always giggles when she does find the right thing, is when I tell her, well, it's a planet, so find something bright, but something that doesn't twinkle, because planets don't twinkle, only stars do. And she's like, okay, okay. And then she'll look at, she'll just look very hard and find the one thing that doesn't twinkle. And she's gotten good at it by now, where she's just like, okay, that's Jupiter, I know. So yeah, I think I guess that would be my favorite planet, because we almost every other day or almost every day try to look for it. And it has so many moons, right? I don't even know that. I know they keep finding like new ones. I think there are like 90 something. I'm not sure how many there are officially, but yeah, Jupiter. I will pick Jupiter.
That is such a cute story too.
Yeah.
Yeah, Jupiter is
I'm
such a
gonna
cool
go back
planet.
and tell her that I said that, and I'll see how she
Oh,
reacts.
yeah. Oh, yeah. I love that story though. That just warms my heart.
Thanks.
Cool. Um, I think the next one is any questions. Does anyone have any questions for Neha?
I don't think so. You pretty much answered everything that I wanted to. So yeah.
Thank you
Well,
so
thank
much.
you. Thank you, really. Thank you for having me. It was so fun. I loved the chat. It was really fun.
Yeah, this was a blast. It's so cool getting to like know so many other people, and it was such a great conversation with you.
No problem. Anytime. It was really fun. And yeah, aerospace is really it is really cool. Engineering in general. So if you if you guys are looking to pursue that going forward in college, I don't think you're gonna regret it. It's great. It has, there's a lot of obviously there's a lot of career opportunities on the type of engineering you choose, and it pays pretty decent too. So
Yeah, engineering is definitely a good job, especially with the growing tech industries
right.
looking for more and more engineers. So yeah,
Exactly. And it's always so great to see more and more female participation in general, anything STEM related. So it's always great.
yeah, and that's why it's so important for role models like you to like set an example of like, hey, women can do this as well.
Right, right, exactly. Well, thank you. That's it was an honor being here. It was great. Had a lot of fun. Thanks.
Thank you so much for joining. Any other questions?
Problem.
You said that you worked at another company before Iridium. Is that right? Or
Yes, I worked at a semiconductor company called Microchip. So I don't know if you guys have heard of PIC, like PIC, PIC microcontrollers. It was they were, I guess they were, not that they're not popular now, but they were more popular back in our day, where we actually had books about, like the assembly language was, oh, this is what PIC microcontrollers use. So they make it's embedded microchips. So they are when we say embedded, it's designed for a particular use. So stuff like so if you look at a Keurig machine, microchip controllers operate, do all the um, automation that the Keurig needs, I guess, in terms of when, the sensors that are needed for when you have that coffee pot go in and open and stuff like that. So they make those, it's not more like it is kind of like a computer, but it's not as, like sophisticated as a chip that goes in an Intel processor. It's more of like, using in like microwaves and, Keurig machines. And those are like the simple ones. We do have some complicated ones that went into like your cars, for example, where, you would have the software that takes care of playing your audio or your Bluetooth and stuff like that. So they made chips, or they still do make those chips. And yeah, so I used to work for design. So that was like pretty much the beginning stage of the chip, where you're kind of designing what the chip should look like. A lot of that part is very like automated. So you kind of just look at the software and kind of see if everything like falls in place and stuff like that. Yeah, so I did that for a few years before coming onto Iridium.
it's super cool. It's cool to learn about like all the different areas people have worked in as well. And
Yeah,
yeah,
yeah.
electrical engineering has a lot of different applications, it sounds like.
It really does. It really does. There's, I know electrical engineers who work in, but like, in the car industry. Like I have a very good friend who works like in Tesla, for example, right? Then, I mean, there's aerospace for sure. They work in like manufacturing, like the ones that are more like hardware centric. Um, yeah, pretty much like, because just everything is so everything has a computer on it, right? So you just software and electrical engineers are pretty much, I think, applicable like everywhere you go. And software even more, right? Because anything that's virtual, you just have somebody in the software industry, taking care of that. So sure.
Such a big field.
Yeah, it is.
Any more
So
questions?
are you guys, I had a question actually just for you guys. Like if you, are you guys like looking to pursue anything in the engineering field or anything STEM related? Do you guys have any prospects you've looked at?
I am looking at electrical engineering or materials science.
Very cool. Very cool.
I'm
It's great to
really
hear.
interested in aerospace engineering.
Ooh, very cool. You guys are not just saying that because I'm both into electrical aerospace, right? I'm just
No.
kidding.
Mm-mm,
No, that's
no.
great. That's great. That's awesome. Aerospace is, yeah, even aerospace, depending on, I guess, um, different paths you could take in aerospace too. I think it's pretty vast and really cool. And yeah, material science is awesome. Like I feel like it's so complex and so relevant these days because there's like chips getting smaller and smaller, and they're all because of the magic material science engineers make. It's amazing. So very
Yeah, it's
cool.
interesting learning about like the materials because people also have to like, I guess, select certain specific materials that go well with certain applications. And I mean, it is a lot of like thinking critically about like what strengths and weaknesses you want. One of the past interviewees mentioned like Pokemon cards and her like as an analogy like of Pokemon cards like they have strengths and weaknesses, so it's cool to know about like
Oh,
what
that way.
how
Okay, I get
materials have these
that's
strengths
yeah,
and
that's really, it took me a second, but yeah, okay, I get it.
yeah, I put that in a strange way.
Very cool. Yeah, no, yeah, it's a very impressive field for sure. Yeah, and it's the physics of it, right? Because it all comes down to the physics calculations of all of that, the materials and yeah, how they work. It blows my mind, especially coming from like the little I know about it from the semiconductor perspective. Like we had material science engineers on microchip too, and really that would be like their only job, right? It's like, and I don't mean only job as in a trivial way. They would do like the most important things where the because they would get these size requirements from the customer, right? That this chip needs to be this tiny, and then the actual chip, the wafer and all that, like that's like really tiny, but they have to figure out like in terms of, for in our case it was more so how to deal with the power constraints, like to make sure that it can be that small and still not like overheat and stuff like that. So that was really cool. I would like pass by their desk and they would have these like complex calculations on the board. And I'm like, I have no idea what this is. I need to walk by. But really, yes, it's smart people. It's really cool. Yeah. It's the same with aerospace too. I have, back when I was in Virginia, most of our aerospace engineer, and even my husband, sometimes when he'll say something and I was like, oh yeah, that's all Greek to me, because it's just, they would talk about these terms. They're very specific terms in when they talk about aerospace stuff, and I was like, what? So, but which is great because I learn. I never learned all that stuff in school, so you also collaborate and learn like that. But yes, very. That's great. I love both those options that you guys said. And yeah, again, if I can answer any questions you guys ever have about any of that stuff, I'm happy to help. And once we end the call, like I'll send you my details.
Thank you so much. Thank you so much for your support too.
No problem.
Any more questions? Okay, I think that was good. Thank you so much. That was so fun. I loved getting to hear about your story and
It
what you
really was.
do,
Me too.
getting to meet
Thank
you
you. Thank you for
finally.
having me. Yeah, really, it was great. We'll continue to connect, and it was a great
Certainly.
initiative. I love the Insta page, by the way. You did a great job. So keep going, and yeah, we're always here to support. So
Thank you so
have
much for
a have
joining
a good
us.
evening. Yeah, no
You
problem.
as
Thank you
well.
so much. Thank you.
Okay.
Thank
Bye.
you.
Bye,
No
everyone.
problem.